Hey, good morning, everyone. Thanks for joining our webinar this morning on the topic of do you control your equipment or does your equipment control you? So we have our speaker, Nancy Regan, here with me this morning, and just want to give you a quick background of Nancy. Nancy has been living and breathing reliability-centered maintenance for over 25, 27 years. She started her career with Naval Air Warfare Center in Lakehurst, New Jersey. She spent about 7 to 8 years there, and then after that, she decided to start her own consulting with her interest and love towards reliability-centered maintenance. And Nancy has been doing this, and she is a very prominent keynote speaker at various industry-centric conferences and events. She's a popular figure in the reliability field, so that's what I can say. And the next thing is she's also the author of the book RCM Solutions, which you can find it online, Amazon. If you want to just buy a copy of this, and we asked Nancy to just come and speak to our audience this morning about the reliability-centered maintenance concepts, and she graciously accepted our request, and here we are. I will turn it over to Nancy. Thank you so much, Nancy, for joining us this morning.
Thank you, Banu. Thank you, everyone, for being here. So today, what I would like to talk about is three of the things that can help you to control your equipment instead of your equipment controlling you. So before we begin with the details, I would like to get to know you a little bit better. So if you wouldn't mind, Banu, can we do the first poll? So the first poll question, if you would take the time to answer it, is what is your position title? What do you do? Are you a reliability engineer, a technician, middle management, upper management, or something else? Can you still hear me, Banu?
Yes, I can, Nancy.
Okay, just want to make sure. We're just giving everyone a minute to answer the poll question.
Sure.
Okay. Should we go on to the next one, Banu?
Yeah, please go ahead, please.
Okay. All right, so the next one will just take 30 more seconds. The next question I have is, if anything, what is holding you back from achieving your reliability goals? And we'll just stop for 20 seconds just for you to click one of those. Maybe it's maintenance and production don't communicate. Maintenance is seen as a cost center instead of a profit center. Maintenance is reactive. There's lack of funding for improvement initiatives or other. Okay, this is interesting. So far, it's almost a tie between maintenance is reactive and it's seen as a cost center instead of a profit center. Yes, I hear that very often. What we're going to talk about today can help us with those two things. So we'll just do 10 more seconds getting the results, and then we're going to move on. And I'm going to share with you one of my other passions other than just reliability-centered maintenance. Okay, so I was in Tunica, Mississippi, and I was playing in a no-limit Texas Hold'em poker tournament. And I was playing really well. And I look up at the tournament clock and there are 30 people left, and then there are 20 people left, and then there are 10 people left, and I'm one of them. That means I made the final table. Then I look up, and before I know it, there are only 2 people left, and I'm one of them. Now, I had been playing really well up until then, but I'm gonna come clean with you. When it got down to just me and my opponent, I let one of life's most deadly forces that can affect a human being, I let it affect me, and that was fear. I got really scared and I started playing fit or fold. And what that means in poker is you fold when you know you're beat and you bet when you have a good hand. Well, my opponent picked up on that weakness and he exploited me until he had 75% of the chips in play in front of him. Now, luckily for me, it was time for a scheduled break. So my husband takes me aside and he says, "What are you doing? You're letting him steamroll you." And I'm telling you, my stomach just sank. And I said to myself, oh my gosh, he's right. I'm letting this guy steamroll me at the poker table. So I go into the ladies' room and I lock myself in a stall and I start talking to myself. What are you doing? You know better than this. You know what you have to do to win. Just go out there and do it. So I steel myself. I go back out there, I sit down, and I start playing smartly. I get a little bit aggressive when it's called for. I throw in a few timely bluffs, and I fold when I know I'm beat. And in 30 minutes, I won that tournament. Now, the question is, what was the difference before the break versus after the break? And the answer is my philosophy. See, when I was in that bathroom stall, I changed my philosophy from a losing one, playing fit or fold, to a winning one. So I got back to the table and I had my mind right and I did the right thing. I started to make winning choices because of the change in my philosophy. Well, when it comes to our physical assets, it works the same way. In fact, we actually design our reliability. So reliability is designed two ways. It's designed literally and figuratively speaking. Now, literally speaking, we can't get anything more out of our equipment than what it was designed to do, right? In other words, it's inherent reliability. It is what it is. But as equipment custodians, we also figuratively design our reliability. So sure, there are things like proactive maintenance. We can decide what kind of proactive maintenance tasks to do on our system, but there's a whole lot more that affects the reliability we get from our equipment. Just things like the operating procedures that we have, the quality of our technical publications and our training programs, the kind of emergency procedures that we have in place, and this is a big one, the operational tempo in the environment in which our equipment works. See, inherent reliability doesn't mean how long an item will last with no failures. It means the kind of reliability that it exhibits when it's protected by the right proactive maintenance and some other default strategies. So in other words, all these things that we do to and for our equipment, all of these things are based on the choices that we make. When we make good choices, we experience good reliability. And when we make bad choices, we experience things like increased cost and chronic downtime and living in reactive mode, running from fire to fire. And then that creates frazzled teams because everyone's running around. Now, the key is that the quality of our choices are governed by our philosophy. So just like the kind of the plays I was making at the poker table was completely governed by my philosophy. Well, the same thing goes when it comes to reliability. So then the magical question is then, what makes up a winning reliability philosophy? And so here's where I want to talk about just 3 of the things today. And the first one is to begin at the beginning. Now, what do I mean by that? Okay, So if we were in a live setting, I would say, could you raise your hand if you've ever been involved in a failure modes and effects analysis, or if you know what one is? And I'm willing to bet that most everyone online today has been involved with one or knows what one is. And if that's the case, then you know that a failure modes and effects analysis starts by writing functions. Now, here is what my mentor, John Mowbray, taught me about reliability. And for me, I like to break things down simply because we could get super complex about reliability, but I like to look at things more basically. I think it's important to start with basics. When you're strong in the basics, it makes your foundation strong, and then everything else follows much more easily. So here's what John Mowbray taught me. He taught me that reliability isn't a thing on its own, but rather reliability is sprinkled amongst all of the functions that we need our equipment to do. So in essence, when we write functions properly, we are actually defining the kind of reliability that we need from our equipment. So when we write functions the right way, it's like goal setting for our equipment. Now, just like human beings, when we wake up in the morning, if we don't have any goals, then we take uncertain steps every day, right? So for example, and I'll tell you, I'm guilty of not doing this sometimes. So in the morning, let's say we wake up and we say, no matter what, I got to get these 4 things done, right? I don't know about you, but there is nothing like checking a task off of my list. In fact, not only do I check it off my list, but then I do this with a black Sharpie. It gives me a sense of satisfaction. Now, I won't try and pretend that I am this super disciplined all the time, because I'm not. Sometimes I end up in a big do loop with myself because I don't do this in the morning. And then you know what happens? I get lost in a sea of email and notifications on LinkedIn, and then I look and I think, oh, this desk is a mess. If only I got organized, then everything would fall into place. So you can really get lost. And the same thing goes for our equipment. See, when we have goals for our equipment, in other words, when we write our functions properly, when we identify specifically what we need from it, then we are able to then identify meaningful steps to achieve those objectives. So really, writing functions for our equipment is like recording our vision of the future for our equipment. Now, if we're going to design our future when it comes to our equipment, then it is essential that we start with clarity about what we need, and we've got to be specific. So, number 1, a winning reliability philosophy starts with clarity about what we need. And I'm not talking about how the design engineers envisioned it being used, and I'm not talking about how the manufacturer planned on this piece of equipment being used. I'm talking about what the organization that procured it actually requires from it. Now, for the next 45 seconds, if we were in a court of law, if you watch, like those law shows, or you watch something on television where there's this really gripping lawsuit and they're in the courtroom, sometimes the attorney will start asking questions, and the other attorney will say, I object. And then the other attorney says, Your Honor, will you just give me a little bit of latitude? So I'm going to ask you for just 45 seconds of latitude here. So when it comes to our physical assets, we define performance in 2 ways. Number 1, design capability, and number 2, required performance. So let's take, for example, a tow tractor, which Banu mentioned that I started my career with the US Navy, and my very first RCM analysis was on an aircraft tow tractor. So this is a little bit of nostalgia for me. So let's take a tow tractor, and let's say that it is capable of towing 30,000 pounds, but what I need it to tow is 40,000 pounds. Is this scenario acceptable? Now, of course, it is not acceptable because the required performance exceeds the design capability of the asset, right? Total common sense. Now let's look at it the other way. Let's say that what it is capable of is towing 40,000 pounds, but we need to tow 30,000 pounds. Is that okay? And yes, of course it is, because the required performance fits within the design capability of the asset. Now, this is such a straightforward concept. It is so simple that it can easily be overlooked. And this is why I asked you for a little bit of latitude. Things that are simple, things that are easy, then it's also easy to overlook it. And in fact, in our world, this has been overlooked a lot of times. If an organization gets this wrong, worst case, it can have very serious consequences, and it can even turn deadly. In fact, it has turned deadly. I'd like to share 3 examples with you. Okay, there were 3 air tanker crashes that crashed while responding to forest fires. 2 C-130s and a P-4 privateer. These crashes happened in 94 and 2 in 2002. For the first C-130, there was in-flight separation of the right wing. All 3 crew members were killed and the airplane was destroyed. The second one, same thing. All 3 crew killed and the airplane was destroyed. And on the last crash, there was in-flight separation of the left wing. And both crew members on board were killed and the airplane was destroyed. Now, there was one common thread that all 3 of these aircraft had, and it was the fact that they were leased by the United States Department of Agriculture's Forest Service for public firefighting flights. But here's the thing. The aircraft were originally designed to transport cargo for the US military. They were not designed to fight forest fires, but they were retrofitted to do so. Now, remember when we talked about we design our reliability, and it's not just the design of the equipment, and it's not just the kind of proactive maintenance that we do. We've got all of these other things in play, especially operational tempo and the environment. Well, when it comes to the operating environment, when you're fighting forest fires, the loads experienced by an aircraft transporting cargo are vastly different. The NTSB recommendation as a result of these 3 crashes, this is what it said, this is what it explained about a firefighting mission. First of all, it stated, and what's in yellow is a quote from the report, that an aircraft experiences frequent and aggressive low-level maneuvers with high acceleration loads and high levels of atmospheric turbulence. The structural lives of the aircraft were shortened because of the harsh operating environment and the far more aggressive loads applied to the aircraft during firefighting versus transporting cargo, right? So required performance versus what it was designed to actually give us. So the report concluded that the aircraft were likely operating outside the manufacturer's original design intent. So what happened is that the required performance of firefighting exceeded the design capability of transporting cargo. That is a very simple concept, and it is so obvious that just as human beings, sometimes the obvious just escapes us. And when a simple concept like this, of ensuring that an asset is capable of doing what we need it to do, when that is completely overlooked, it can end up in disaster. And that is an extreme example of why it's so important to begin at the beginning. Now, even if an organization takes the time to write functions, this is, in my experience, it's often done as just a matter of routine. And those functions lack the required details. And it's often because they're not asking the right people. So I want to give you, this is a real world example. A few years ago, I was hired by a company to review an RCM analysis that they had done on an air compressor. And it got very poor results. So they hired me to just have a look through it and to let them know why I thought they didn't get the results they needed. So that's what you see, what I'm going to show you on the left-hand side. Now, on the right-hand side, I'm going to show you functions from a real-world air compressor analysis that I analyzed that we got effective results from. So I can illustrate what I mean by begin at the beginning. Okay, so poor results. these are verbatim functions from this analysis. Deliver compressed air to the tank. Well, see, the thing about that function is it describes just about every air compressor out there. Another one was filter and remove particulates from intake air. Again, another function that could describe just about any air filter. And monitor pressure level. It's very vague, it lacks detail. Now let me show you some of the functions from an analysis that I facilitated. And this was our primary function. To provide compressed air that is oil-free, less than 95 degrees Fahrenheit, at a minimum of 3,500 standard cubic feet per minute, 100 psig output pressure, with a minimum of 5 psig rise to surge, to make up this compressor's portion of maintaining 11,000 standard cubic feet per minute and 90 psig head of pressure to the plant. So notice in this function that we have been very specific, not about what this compressor was designed to do, but what we need it to do. And you also notice that in this function, we make clear that this compressor makes up part of what is required of the plant air. So it's not the only working compressor. It's very specific based upon what the plant needs. Okay, the next one, to remove particles greater than or equal to 1 micron from the incoming air to the compressor. So you can see the difference between this vague function and this one that is more specific. And finally, to indicate main pump oil discharge pressure within plus or minus 3 psi. Again, we've been very specific about how well we need our pressure gauge to indicate. So when we take a step back and we look at this, on the left-hand side, this is writing functions as a matter of routine. And this is how we define reliability. So the moral of this story is, before we can figure out what kind of proactive maintenance we should be doing, or if we need to make any improvements to maybe our operating procedures or our training programs, we need to get clear about what we need from our equipment. Now I'd like to pause just for 30 seconds and let's do another poll. And this question is, does your organization have a process to formally consider required performance from your assets? Now, on purpose, I italicized the word formally because it needs to be more than, maybe a couple of people getting together and having a chat about it. So if you could just say yes or no, and we'll just take another 20 seconds on that poll. Okay, so far it's almost 50-50. It's 53% no and 47% yes. So for those of you saying no, for the half of you saying no, in my experience, I have facilitated analyses that while we're identifying functions, we figure out the cause of chronic failure. And it was actually just a few months ago, I was facilitating an analysis, and we got it was about a day and a half into the analysis, and we actually stopped doing the analysis because we figured out that they were using the equipment in a way that the equipment wasn't meant to be operating. And that was the reason for the chronic failure. So we kind of switched gears and figured out what we could do about that. So it can be really valuable and really eye-opening. Okay, let's go on to number 2. The second one, so that we're going to just talk about 3 things today. And the second one, what makes up a winning reliability philosophy? Well, if we go back to our failure modes and effects analysis, remember we started with functions, but another step in the process when we write failure modes and effects analysis is we write failure modes. Now, one thing I want to make clear, let's just have like I call it a training timeout. When I use the term failure mode, this term means different things to different people. So for purposes of today, when I use the term failure mode, I'm talking about a failure cause. I use those 2 terms synonymously. So when I use the term failure mode, I mean what specifically causes a functional failure. In other words, what specifically causes us to not get to not do this function that we've said we needed to do. Okay, so number 2 is we manage physical assets at the failure mode level. This is another valuable thing that my mentor, John Mowbray, taught me. And I can hear him saying it because he said it to me so many times. We manage physical assets at the failure mode level. So if that's the case, then when we identify failure modes, we have to make sure that we, number 1, write them at the right level, but also that we write them in the right amount of specificity so that we can figure out how to manage them properly. Now, remember how we talked about how we take uncertain steps each day, but when we have goals, then we're able to know what we need to do to get what we need. Well, that's the same thing. That's why we're writing failure modes. We're writing failure modes so we can figure out what steps we have to take to achieve our objectives. Now, here's a very simple way of thinking about a failure mode. This is the way I think about it. A failure mode is like a road. And if we were live right now, I'd be walking across to the other side of the room. Where when you're on the right road, in other words, if you have your failure mode written properly, then you can arrive at your destination, which is proactive maintenance tasks and any other default strategies, like maybe we need to beef up an operating procedure or change a tech manual, or maybe we need to do a failure finding device on one of our protective devices, things like fire systems, those devices that are intended to keep us safe in the event that something else goes wrong. So you see, if we're on the right road here, we get to where we need to go. But when we don't write them the right way, you know, we end up, we either write our failure modes so detailed that we end up with analysis paralysis, or they are so high level that they're so superficial, we can't make any meaningful decisions. So again, let me show you some real world examples. And I want to go back to that analysis, that one that I reviewed and one that I facilitated. So on the left-hand side, this is the analysis where the functions were written and the failure modes were written as a matter of routine. Okay, so deliver compressed air to the tank. These were 2 failure modes, intake filter clogged and intake filter damaged. Okay, those aren't so bad. Let's compare them to some that were included in this other analysis. Intake filter clogged due to normal use, intake filter deteriorates due to normal use, and intake filter damage due to improper installation. So you see how these are kind of vague, and I have to almost guess a little what it is I'm going to do about them. For example, when I write it in this amount of detail, then I can decide to monitor the differential pressure and replace the filter as required. For this one, maybe I might decide to replace the filter on a scheduled basis because I know that after a certain amount of time that the filter element is going to degrade. It has a useful life associated with it. And with this one, if I get a little bit more detailed that it's damaged due to improper installation, then I can institute a training procedure, or I can augment the maintenance instructions to stop that from happening. Here's another example where the function still on the primary function. This was in the analysis valve failure. Well, first of all, what valve are we talking about? And as a facilitator, I wouldn't ask how did it fail or why did it fail. The question you want to ask your team members is this: what specifically caused the valve to fail? That really helps your team members to zero in on the question that you're asking. What specifically caused it to fail? Well, how about the intake air valve controller drifts out of adjustment due to normal use? If that's the case, I may decide to calibrate the valve at a specified interval. So you see, when we get more detailed, we are able to identify what we want to do to manage that failure mode. And that's all those things that were coming in at our system. This is how we design our reliability. We either make good decisions or we make poor decisions for our equipment. And let's look at one more. This is another real world example. AC motor seizes due to excessive vibration, overheating, and electrical failure. Okay, so we got a whole lot of stuff going in there. We got some failure effects and we've got more than one failure mode in one. So, I mean, this is gonna make your team go in all sorts of directions. So we need to be a little more focused. So what specifically causes the AC motor to seize? Maybe the motor bearing oil deteriorates due to normal use. So maybe I might decide to replace it on a regular basis. Maybe the intake screen clogs due to normal use. So maybe I might want to clean it on a regular basis or do condition-based maintenance and monitor the differential pressure and only clean it when it needs it. For motor bearing seal leaks due to normal use, well, you know, in this case, there's probably nothing we can do to predict or prevent it leaking, but we can monitor for leaks on rounds, for example, and catch it in enough time before it becomes a big problem. If the electric motor bearings wear due to normal use, well, maybe I might want to do some vibration analysis on a specified interval, but based upon the right technical characteristics. Okay, so that's it for number 2. Now let's go into number 3. What is the third thing that we're going to talk about today that makes up a winning reliability philosophy? So if we go back to our failure modes and effects analysis, if we do, now what you're looking at is, one thing I didn't mention is that this is a functional FMEA as opposed to a design FMEA. So, you know, if you're doing a FMEA in the design stage, you may be like at the nut and bolt level, and that may be necessary for a different application. So if we're doing an analysis to come up with good proactive maintenance and other default strategies, I would do a functional FMEA, and that's what you see here. Now, one of the pieces of gold that you can do is to write a failure effect properly. So you have all the different elements. So what happens when that failure mode occurs? And we can get very detailed about it, right? Like metal to metal contact, right? Now vibration levels increase. Now we've got excess stress on the shaft. Vibration levels increase. Now we're going to get an alarm text on the info tab. So by writing it this detailed, we're writing clues. So when we get to the back end of an analysis, we are in a position of strength to try and figure out how to manage it. So we do all this upfront work first, and then we're ready to make decisions. Okay, but the thing is that doing a failure modes and effects analysis properly requires a lot of information. So it begs the question, where do we find the information required to formulate all of these strategies? I have yet to come upon an organization that has all of the historical data that they need to do a complete reliability analysis. There just are always holes because we live in the real world and not fantasy land. So if we go back and we take into consideration these aircraft crashes, I want to talk about what happens after an aircraft crash, because it gives us the way forward to properly do an improvement initiative when it comes to reliability. So in the United States, when there is an aircraft crash, they immediately dispatch what's called a GO team. And on this GO team, there are specialists in all of the specific areas of the aircraft that crashed, right? They have operations and structures and systems and power plants, weather, air traffic control, survival factors, someone from the FAA, the aircraft manufacturer, the engine manufacturer, and so on. Some GO teams have up to 35 or 40 disciplines on it. Now, one of the deadliest aircraft crashes in United States history, I pulled out some quotes from a couple of the people involved in that crash investigation, because they give us not just the clues, but they basically straight up tell us what we need to do to take care of our equipment properly, or where we find the information we need. So this first one, his name is Gregory Fife. He's a former NTSB lead investigator. He said that a go team is a natural system of checks and balances. You get a lot of information. You have everybody looking at everybody else. They would provide information that you may not normally get if you were trying to do the investigation by yourself. Now, another guy who happened to be a journalist, he said the airline, of course, they're part of the go team. The engine manufacturer, they're part of the go team. Every subcontractor, they're part of the go team. They allow these people to be on go teams for an understandable reason, because they're the people who understand the mechanics, the physics, the chemistry of the individual items. They can actually be helpful in an investigation. Now, the reason is because all of these people have all different perspectives, right? If you take an operator and you take a maintainer and you take a design engineer and a systems engineer, each one of those people has very important knowledge about a piece of equipment, but their knowledge comes from only their perspective. So they can give us information based upon their experience and their knowledge, but it's going to be different than a different discipline's perspective. So when it comes to a go team, from an aircraft crash and a working group for any reliability improvement effort that you might want to do, if you're going to do a team approach, the question is, what is the key difference between a crash investigation and a reliability analysis? And for the most part, the answer is that a go team is reactive. And when we do improvement initiatives, those initiatives are proactive. Now, I want to share one more quote with you. And this one came from that Gregory Fife. He was the former NTSB lead investigator. Here's what he said. The best way to characterize any aircraft that has an in-service use is that it's like wine. They get better with age. Why? Because we get a better understanding of the airplane. We identify the deficiencies. We correct them. So over that period of time, the plane becomes better. Now let's step back for a second, because you may be saying to yourself, why does she keep talking about airplanes? Maybe there are some of you out there right now who are responsible for aircraft, but maybe you're responsible for compressors or in a plant or an offshore oil platform or a fleet of mobile vehicles. It doesn't matter, because if we replace the words aircraft, airplane, and plane with asset, it applies to us. So it's all about that understanding, not just about the technical characteristics of the equipment, but also how it behaves in the operating environment and our operational tempo in the environment in which we expect it to work. So to sum it all up, the last thing that I wanted to talk about, one of the ways that you can start to take control of your equipment instead of it controlling you is to get the people who know the equipment best involved in improvement initiatives, whether they're formal or even if they're informal, even if it's just, querying operators and maintainers. Anything, of course, would be better than nothing. And the other thing is, one really important byproduct that comes from this is, if you're doing a formal improvement initiative, a formal analysis, and you are using a facilitated working group approach, what you're doing, if you've got the seasoned experts around the table, you are actually documenting their 10, 20, 30, 40, 50 years of experience. You are memorializing that knowledge and that experience. So if someone decides to maybe resign and move on to another position, or someone retires, all of that information doesn't leave with them. You've had the opportunity to take it and memorialize it, and that can only help moving forward. Okay, so the last poll before we wrap up and get to questions, the last poll question, if you wouldn't mind doing, is this. Does your organization formally involve a multidisciplinary team of equipment experts when making decisions about your assets? So my question is not just like maybe walking around and asking questions, but do you actually have a formal process instituted where everyone takes part? Okay, so far it's trending 70% no, and okay, now we're at 60% no and 40% yes. And that's actually higher than some of the other polls that I've taken just from people raising hands when they're in the audience. And, you know, if you're one of those people who said no, you know, definitely don't feel badly or think, oh my gosh, I'm not doing anything right, because it's more the exception. It's more the norm rather than the exception, because, you know, these things take time. And like we had a poll at the beginning, you know, a lot of times it goes for our own personal lives as well as when we're, you know, when we're out working. There's a lot of stuff that goes on, right? And there's a lot of unplanned failures that happen and things that come up. I mean, you know, we're in the midst of one right now, this, you know, this coronavirus. And sometimes we just have to do what we have to do. But if we really want to take control of our equipment, we have to make getting proactive a priority. And it starts with the basics. It starts with forming a foundation. Now, I think anyway that I have made it through this entire presentation without saying 3 of my most favorite words in the whole wide world. So a question to you is, what is the process that I just described during this presentation? And essentially, I just described reliability-centered maintenance, right? So if you're not familiar with it, RCM principles are over 50 years old. They have stood the test of time and human meddling because they work. It's kind of like if you're going to make like crawfish étouffée, you have to start with a roux, right? And you have to, you know, you have to cook it, and you have to cook it for a while. You really have to make it brown and get all the flavors just right. I mean, that's just the basics. That's just where you begin. You begin with the roux. That's how I often think of reliability-centered maintenance. Now, a couple of final thoughts here is this. Some of the misconceptions, there are a lot of misconceptions about RCM. One is that it takes too long and it's too expensive to do. And yes, it takes time and it takes resources, but when it's done right with the right people, the results can be transformative, and you can efficiently complete analyses. Another misconception is that you have to do RCM on all of your equipment, and that's just not true either. You can do RCM as broadly or as narrowly as you want. You could do it on an entire plant, although I don't know that there would be enough time to do it on everything. You could do it on just an air dryer system. You could do it on just the compressor. You could do it on just an electric motor. You could do it on just a few failure modes. But the other 3 things are these. A FMEA, or a failure modes and effects analysis, is embodied in the RCM process. That's steps 1 through 4. When you throw in step 5, failure consequences, now you have a FMECA, or a failure modes, effects, and criticality analysis. And a question that I get asked very frequently is, how do I know if I should do RCM or CBM, condition-based maintenance? But here's the thing. Condition-based maintenance is embodied in the RCM process. It's embodied in step 6, proactive maintenance and intervals. So just to sum everything up, we talked about 3 things today. 3 things that help us to take control of our equipment instead of it controlling us. Number 1, get clear about what we need from our equipment, not what it was designed to do, but what we need from it. Number 2, specifically identify what would cause us not to get that kind of reliability that we need from our equipment, because that puts us in a position of strength to be on the right road to decide what to do about each of those failure causes. And number 3, use your equipment experts within your organization. They are most often the most truthful source of data. So that sums up what we talked about. So if I can just mention a few more things. Number 1, if you have any questions, feel free to contact me. But if you maybe didn't put it in, I know you weren't able to type it in the poll, I would love to know if something is holding you back from getting the reliability that you need. I'd love to know what it is. So I invite you and I welcome you to email me with that. Another thing is, if we are not already connected on LinkedIn, I'd be delighted by a connection request. Every week I post a different video about maintenance and reliability. And I have a special request from you, and it is this. I have something really fun and exciting up my sleeves. And one thing that would make it even better is if I could go live on YouTube, but I need 1,000 subscribers for that. So if you're a YouTube user, if you could go to my YouTube channel and just subscribe, that would be really wonderful. Okay, so finally, to just end all of this before we get to questions, like I mentioned, we only talked about 3 things that we can do to take control of our equipment, but there are more things, we just don't have time for them. But when I was in Hartley Whitney, England in last September, and I was there talking about, I'm going to be announcing RCM certification soon. And I was there for a meeting, and I shot a video, like an introductory video about reliability-centered maintenance. And I actually turned that into an online course. So if you would like to enroll in that, it is completely free. You just go to this URL and you can just sign up and you can get access to the online course. It's all pre-recorded and on-demand videos, and it's me walking around Hartley Whitney talking about reliability-centered maintenance with some other special screencasting and some examples thrown in there. So I sincerely thank you for your attention today. And now if you have any questions, I'd be delighted to answer them.
Yes, thank you, Nancy. Great presentation. So I have 2 questions here, if I may just read you through.
Okay.
The first one is, in RCM, should we do it from design phase? Why?
Oh, yes. Okay. So in a perfect world, you can absolutely start reliability-centered maintenance at the design stage. And that is because that is your opportunity to get clear about what you need, so that you design it exactly how you need it to work. How often have we procured a new piece of equipment and we get it in the field, and now we have to do some workarounds, or we have to, add something to it because it doesn't need what we have. And actually, when I was a Navy employee, we were doing an analysis on an air start unit for engines on aircraft carriers. And the Navy was still in procurement negotiations with a German company. And we did an RCM analysis while they were still in the design stage. And because of our analysis, we came out with several design changes. But the eye opener was this. There were 2 German engineers who flew over for this RCM analysis, and we had users of current air start units. Now, although they didn't know this new design, they knew the operating environment. And there were several moments in this analysis where the German engineers, they sat back in their chair and they said, oh my gosh, like I had no idea that the operating environment was that harsh, because it was used on board an aircraft carrier. So if possible, yes. Now, if you have a 40-year-old piece of equipment, then don't feel lost, because one of the most successful analyses I've facilitated is the CH-47 Chinook Helicopter. We started that 40 years after it was fielded, and we had enormous beneficial results from that analysis. So it doesn't matter if it's not even finished being designed, or if it has been in the field for 40 years.
So the next question is, what is the difference between failure mode and failure cause if you say they are the same? Because we refer to both the things interchangeably. So what does that really difference mean between the
Okay,
cause and the mode?
yeah, I mean, some people use the term failure mode to be the first part of a failure effect, like bearing seizes. Some people consider that the failure mode. And then what specifically caused it to seize? Well, it was lubricated improperly. So it really just depends on what term you want to use.
Okay, thank you. So the next one is, can RCM be improved? And is RCA also a proactive or only reactive tool?
Okay. I mean, generally speaking, reliability-centered maintenance is proactive, right? But if you consider root cause analysis, root cause analysis is reactive, but really root cause analysis is identifying, failure modes or failure causes. It's what specifically caused, that functional failure. So it's meant to be proactive, but the principles are often used in our industry in the form of root cause analysis.
Okay, thank you. The next one, Nancy, for you is, for starting of RCM, should we use a predefined failure mode of similar asset, or RE needs to start with their own failure modes?
Okay, the answer is yes, but you have to be really careful if you come to the table with like failure mode libraries, or if you're using another analysis, someone else's analysis. So number one, it can be very beneficial. Like, let's say we do an analysis on an air compressor, and now we have another one on the other side of the plant that's used for something completely differently. And the air compressor is a little different. We can take our first analysis and template it. So we could use those failure modes and those failure effects and just edit it so it's applicable for what we're doing. That's totally fine. But you can get into a serious do loop if you use failure mode libraries. If sometimes they are really, like, they go down to the nut and bolt and resistor level, and that might not be what you want. So sometimes you can end up spending more time trying to massage that data than to just do it from scratch yourself. So it really depends. You just have to take a look at the library or the data that you have and use your common sense and say, is it close? And will I spin my wheels by using it or not?
Okay, thank you. So next one is, it's a long question. So performance standards are normally written according to design, not according to what we require from assets. If what we require from assets is higher than the design, this means many wrong things, such as we can require much more than the asset is designed, which is not correct. It opens the door to put wrong function assumptions, and then we deviate from designs when we put functions so that the reference is not the design. So what we need from the asset is already stated when we design it. So we should not request more than this in the FMEA, because this means that we are misusing our equipment. So there needs some clarification about how do we expect this when you define some things ahead before things are put in place for operation by somebody else in this case. So that's a great question. I mean, normally most people inherit the things that some designers put in place without knowing what the functional requirement level is, right? So,
yep. Okay, so here's how I would answer that question. Number one, if you're doing a proactive analysis, whether it's RCM or something else, and if it involves writing functions, then you need to write what you need the equipment to do, not what it was designed to do. Now, here's the difference between design specifications and equipment functions. And this is often mistaken in our industry, right? A design specification details what something is, right? Okay, so I want it to have 4 wheels, and I want it to have a closed cabin, and I want it to be able to go from 0 to 60 in 3 seconds, okay? Well, that's kind of, okay. So the design spec details what it is. When we write functions, we need to write what we need it to do. And if you do that in the design stage, then the design engineer can design what it is so that it can accommodate what you want it to do. So I hope that answered the question, but the moral of that story, the gist of the answer is design specs is what it's supposed to be, and functions are what are when we write what we need it to do.
Okay. So the next one is in design stage, there is no adequate access to failure modes. So what reference can be used in these cases?
The best reference are your equipment experts. Like I mentioned with the Navy Air Start unit, I mean, we had the Navy equipment experts. They had no idea what the design was all about until they got around the table. But we didn't need them there because to tell us about the design. We needed them there to tell the design engineers what they needed it to do, and how they needed it to do it, and how often and how frequently and under what circumstances. I mean, when you're on an aircraft carrier, you know, this thing can be rolling and you can be in bad weather, etc. So the best place to start is with your equipment experts.
Thank you. So the next one, I have a few more minutes to answer. So can you advise any good RCM tool having listing the failure mode libraries by asset types and classifications, perhaps?
You know, no, I don't kind of go out on a limb and recommend them. What my recommendation would be is, if you have one, like I said, take a look. If it's at the nut and bolt and resistor level, and if it looks more like failure effects than an actual specific cause of failure, then I'd be very cautious about that. Now, if you find one, you know, maybe for like a centrifugal pump and you've got, you know, grease dissipates or greased improperly, you know, bearing just wears due to normal use, I mean, you know, those are common sense failure causes, and I would say you can definitely sanity check and use those. So I would just say, whatever you have, take a look and make sure you're not going to be spinning your wheels.
Sure. So the next one I have is, can we increase the reliability of the equipment by performing more maintenance?
Okay, you can never get more than the inherent reliability out of a piece of equipment by doing maintenance, right? You can never raise it because it is what it is. That's what inherent reliability is. But in most cases, organizations are not properly taking care of their equipment, so they're not achieving that inherent reliability. So by doing a proactive analysis like RCM or something else, here's inherent reliability and here's where you are. By doing the right stuff, you can start to achieve the inherent reliability. But if this is your inherent reliability, no amount of proactive maintenance is going to move that. You're going to have a design change to move this, or change your requirements so you require less from it.
So the next one, from your experience, do you see the reliability professionals getting equal chance during the design phase or stage of the equipment? From your experience as you go and talk to your customers and industry.
You know, no. I mean, I think that generally the equipment experts are not involved. So if that's your case, in the people in the audience, if that's your case right now, I don't want you to walk away feeling badly, because that's really the norm. And so, Banu, I had another thought and it escaped me. Will you say that question one more time for me?
So do you see reliability engineers in the organizations get a chance to opinionate while making the equipment decisions, or
Yep.
they're being brought after the fact?
Okay, and so here's where I had the answer in my head. So in my career, I've worked with a lot of different organizations, but there have been a handful that like, for example, with CH-47, I worked with them for 11 years. When I was a Navy employee, I started that RCM program on naval aviation common support equipment. in 1997, and I'm so proud to say that RCM program is still going strong today. I worked with another plant in Tennessee, and the common thread there was, number one, they did not have a firm grasp of the fundamentals. See, there's something else about reliability-centered maintenance, is that, you know, it often gets a bad rap, but even if an organization never formally does an analysis, what is, if you take this RCM nutshell course, this free course, what it highlights are that the basics of many of the basics of maintenance and reliability are embodied in the RCM process. And whether you're talking about equipment reliability, or you're talking about physically exercising your own body or eating right, it's consistency. It is exercising the fundamentals and doing them over and over and over again, and making them part of your philosophy and your culture. That is what is going to propel you. You know, too many organizations today, they have what I call shiny object syndrome, right? Well, let's just buy the expensive software program, or the expensive condition monitoring device. Now, I'm all for technology. I wouldn't want to live without it, but too many organizations, they're looking for the quick fix, the silver bullet, right? That doesn't exist. If you want the quick fix or the silver bullet, we're all gonna have to move to fantasy land. But while we're all living in the real world, then we need to get consistent with the fundamentals. And see, one of the things, okay, I'm gonna use one of my props. See this funnel? One of the things that reliability-centered maintenance helps you do when you involve the equipment experts is you take all of this information, right? It's like if you try to put oil in your car just like this, it spills everywhere. That's why we use a funnel, right? Well, RCM is the same way. You know, you put all of the information, what you need from it, what's causing it to fail, all of that, and it allows you to come out with the steps that you need. So in those three cases that I told you, with the Navy and the Chinook and that plant in Tennessee, they had no foundation. They had no basics down when it came to maintenance and reliability. And one of them is they were not including the equipment experts in a formal analysis. So I kind of went on there a little bit.
No, that's good. I mean, thank you so much.
You're welcome.
Thank you so much, Nancy. Again, we're 2 minutes past the time. So,
all right.
Thank you so much for doing this for us and the audience this morning. And again, as you exit the webinar, please do take the survey questions. If you want to get a direct consultation from Nancy or any questions, please feel free to take that survey and respond to that. So Nancy will be able to reach out to you guys at a later time. So again, we'll send out the slides after this event, and also we'll send you a link to a recorded version of this webinar for you guys to go and watch it again in future in the case. Okay. Thank you so much, Nancy.
Thank you, Manu, and thank you, everyone. Have a wonderful day. Stay safe.